So the next topic is related to the smart grid. It is a monitoring and control of renewable energy systems. So what is the advantages of the smart grid? Because here we can directly say that it is a energy distributed energy generation. Distributed energy generation means we can able to generate the energy in the local market and directly we can integrate it into the actual grid also. So that is why we can say here monitoring and control of renewable energy systems. Here the smart grid is again classified into microgrid. So microgrid means the different renewable energy sources generated separately, which has to be integrated into the central grid. So the renewable energy, for example, I am planting the solar panel on my home, rooftop panel. So it is called as a microgrid. So the consumer can use the microgrid in their home. Even if I have a 50 acres of land, I can install the 100 kilowatt panel in my home, in my farm. I can generate the energy and again I can able to utilize the energy. Here, the purpose of the monitoring and control in the smart grid is we need to gather the information and communicate the data which is generated in the all the renewable energy systems. For example, here the renewable energy source. One is a wind energy, another one is a solar energy. So wind energy means when the wind is available, it can generate the electricity through the wind energy systems, turbines. As well as in the solar, we can say it depends upon the weather. From day to night, we can able to generate the energy. From night to day, that is a morning to evening, we can able to generate the electricity. From evening to next day of morning, that then during the night we can't able to generate the electricity in the solar grid. So the we need to assess all the data, how much energy we are generating in the renewable energy sources, as well as and how much electrical energy generated through the conventional source. It means conventional means we can using a coal as a major fuel for generating the electricity. So those information we are conveying to the smart grid, and this information conveying to the smart grid, and weather and forecast. So natural climatic condition has been predicted to the smart grid, and the interconnected smart grid. It interconnected means every state is going to be integrated with the smart grid. So this is a state 1, state 2, state 3, state 4. So likewise, all the states are interconnected. And again, the demand response. The demand response means, so here this is the supply, and here this is a consumption end. So consumer end. So from the consumer end, we can say, so in the consumer end, we can say how much electricity we are utilizing. Those data is also sending to the smart grid. So here the consumption and the supply will takes place. So supply, how much energy we are supplying, minus consuming, how much energy we are consuming. Whether, for example, I am generating 100 kilowatt, the consumption will be 90 kilowatt. We can able to predict that we have a extra 110 kilowatt of excess energy we are generating in the generating station. Suppose I am generating 100 kilowatt. Again, the consumption needs 120 kilowatt. In this scenario, you can say we need a additional power requirement of 20 kilowatt. So here we can directly use the distributed energy source, that is renewable energy sources we can able to use in the particular system, and we can able to supply those demand to the consumer end. So these are the information we need to assess for the smart grid. So while talking about the smart grid, we can say the microgrid is a local. Microgrid means each renewable energy plant. It is simply called as a microgrid, and it creates the energy for the nearby consumers. So instead of sending the energy to the central grid, we can able to distribute the energy to the local area, and we can able to earn through this program also. Either we have a sufficient energy, we can uh, push the remaining energy to the government, or else we can take the energy from the government also. So that is a function of microgrid. While talking about the microgrid, it has a three independent characteristics. One is a independent, second one is a microgrid can disconnect from the central grid. What is the meaning of disconnect from the central grid? If I am generating a more energy, for example, I am having a home, I am installed 5 kilowatt panel. Actually, I am using only 3 kilowatt. So the remaining 2 kilowatt is the excess energy which is available in my home. I can directly sending these 2 kilowatt to the central grid, or else these 2 kilowatt can be stored by the consumer also using a batteries. So I can place the battery, then I can store the 2 kilowatt to the battery also, instead of sending those extra supply to the central grid. I can directly disconnect from the system. I can use the own energy for my purpose. So that is called as a disconnect, or otherwise it is called as a islanding capability. Islanding means it is a isolation from the main grid. So if any problem is happen in the grid, so what happen immediately, the excess energy will be taken by the grid. So to avoid those things, we can able to isolate the system from the central grid. And also, if any outages which is going to be happen in the central grid, it does not going to be affect the microgrid options. So I have a rooftop panel. For example, the blackout is going to be happen, or brownout is going to be happen. There is a disruption of supply is going to be happen in the local area. So during the day, entire day, the area doesn't have a power. So during this condition, I have a rooftop solar panel. I can use my energy without any disturbance. So we can directly isolate from the central fault. So the fault cannot affect the renewable energy plant which is placed in our home. So here there is a different topologies of the microgrid. So here we can say different topologies of microgrid means the generation capacity we can say classified into AC and DC. AC means it is called as a alternating current, and DC is a direct current. So most of the appliances which is working in our home is a AC. So here the topologies can be classified into AC microgrid, DC microgrid, and another one is called as a hybrid microgrid. What is the difference between three microgrids? The first AC microgrid is the source which is generated as a AC output, which can be interfaced through the AC bus. For example, this is an interfacing structure. In the interfacing structure, the connecting point or connecting port will be the AC source only. So now you can consider the scenario. The solar panel is going to be generate only DC supply. So here I need a converter. The purpose of the converter is converting the DC to AC. So the whatever the energy I am generating to the solar panel, I am converting the DC to AC, and I am connecting to the interconnecting port, that is called as a PCC. This is called as a point of common coupling, which is integrating the different sources in the single point of common coupling, PCC. So the solar panel DC supply is generating, it is sent to the PCC with the help of converter. Here, in the case of wind energy, there is a two possible option is there. Either we can use a DC turbine systems, or the DC generators, or we can directly use the AC generators. If most of the wind turbine is equipped with the AC generators only. So whatever the energy we are generating to the wind turbine, it is a AC. We can directly integrate it to the PCC. Suppose we have only DC type of generator available in the small turbines. Here we need to stabilize those generating values with the help of DC to DC converter. DC to DC converter means we need to first stabilize the value. After stabilizing the value, we are converting using a converter from DC to AC. After conversion value, we have to connect with the PCC. Here energy storage. Energy storage, you can see minus and plus, it is a DC source. Again, we need to stabilize the value with the help of DC to DC converter. Again, we have to give to the DC to AC converter, and AC is integrated into the point of common coupling. Again, load. So the manageable loads are directly connected with this point of common coupling. So all the generated values are sent to the grid with the help of these lines. So whatever the energy we are generated, according to the AC point of common coupling, this is the AC source point of common coupling. we need to convert all the energy into the AC form. If I am generating a DC supply, no matter, I have to employ DC converter to AC converter. We need to convert the supply from DC to AC, and I need to send only AC supply to the point of common coupling. This is called as a AC microgrid. If it is a DC microgrid, so no way. So this is called as a DC bus. Here it is called as a point of common coupling. The PV panel directly generating only DC supply. Here I am using a DC to DC converter. DC to DC converter has a three type of function is there. One is a buck, another one is a boost. It means that we can simply say step up the value or step down the value, or else simply we can say it stabilize the voltage or current which is generating in the renewable energy source. So the PV panel generating a DC. With the help of DC to DC converter, we are connecting those to the point of common coupling of DC bus. So wherever we are generating different types of DC energy, which is connected to the central common point of coupling, that is called as a DC bus. Here windmill. Here already I said the windmill is most of the windmill employing the AC generator. So AC we are generating. Here we are adapting the AC to DC converter. So the output will be the DC. The DC is connected to the point of common coupling. The battery bank, usually it was a DC. We are employing a DC to DC converter, and again it is connected to the point of common coupling, as well as the load. So we are using a EV vehicle. So in the EV vehicle you can see the charging adapter will be given to you. The purpose of the charging adapter is all the batteries only going to receive only the DC signal. So directly we need to connect a DC plug point to the charging area itself. And again charging places like super capacitors and any direct grid can be connected with the help of DC to AC converter, and it directly export all the powers from different sources to grid also. So wherever we are generating a different type of energy in DC form, we are connected all the power together in a certain bus. That bus is called as a point of common coupling. Immediately it will be calling as a DC microgrid. Microgrid is nothing but I am generating a small form of energy. Person 2 is generating a small form of energy. Person 3 is generating a small form of energy. So the person 1, person 2, person 3. So he is generating a 5 volt DC. He is generating 3 volt DC. He is generating 2 volt DC. So all the DC supplies are interconnected. So the connecting line, it is called as a point of common coupling. Again, we are connecting only DC supply. So it is called as a DC bus. If I am connecting a AC supply, it is called as a AC bus. This is the topologies of the microgrid. Next one is the AC and DC microgrid. Here you can see the difference between AC and DC microgrid. This is a AC bus. This is a DC bus. AC bus means all the supply, which is whatever the supply we are generating, either in the form of DC or either in the form of AC, we have to integrate only AC at the particular connecting point. Either load or a generating station or battery bank, whatever the case, we have to integrate only the AC supply in the particular common connecting point. Here DC bus. DC bus means whatever the energy we are generating, we have to connect only through the DC port itself. So that is called as a DC bus, DC microgrid. So PV panel directly have a DC supply, so we can directly use the DC supply here. Suppose I am using a wind turbine. The wind turbine generating AC, I need to put some converter AC to DC converter. Again, DC can be integrated in the common bus. So this is the difference between the AC microgrid and DC microgrid. Now next the thing is hybrid. Hybrid is a combination of AC and DC microgrid. Now you can see this is a common central grid. The central grid, it is only going to generate only the AC supply. It is the fuel, most of the fuel we are using only the coals. Through the coal we are generating AC supply in the particular grid. Here the wind turbine directly generating a AC. Diesel generator. Diesel generator also going to be generating a AC and AC load. This is a AC load. This is a DC load. And as well as the PV network, it is going to be generating a DC. This is a energy storage system. Battery generating a DC. This is a motor we are connecting to the line. It may be AC or DC. Another one is a DC load. These are the 3 points are called as a loads. So these are the generating station. Here it is a load. So whatever we are connecting, the both the AC and DC integrated in the grid, that is called as a hybrid microgrid. It has a topology of both AC and DC output. And also the whatever the converter we are placing over here, this is called as a bidirectional converter. Meaning of bidirectional means here the DC load is using. I am using a AC supply. The bidirectional converter converting AC to DC in the secondary level. If the input is coming as a DC, the DC is converted into AC. So there is a possibility of conversion of both the level, AC to DC and DC to AC. So that's why it is called as a bidirectional converter, and otherwise it is called as a hybrid microgrid. It is suitable to connect both the AC generation as well as the DC generation. In this fashion, we are controlling the entire renewable energy systems going to be integrated into the electrical grid. The main point of control and the distribution of renewable energy sources, whatever the energy we are generating, that is called as a simple microgrid. The small amount of energy which is generated by the consumer, it is we can call as a microgrid option. Thank you. So in this video, we have elaborated about the what is the control of smart grid. Control of smart grid in renewable energy source. So in the renewable energy source means we are generating a small amount of energy in different area. So whatever the energy we are generating to the renewable energy plant, that is simply called as a microgrid. From the microgrid, we have a three options. One is a AC connection, DC connection. Another one was a AC plus DC. That is a hybrid option. So in a hybrid option, we are using the bidirectional converters. The bidirectional converters means the AC can be converted into DC. The same converter has been used to convert from DC to AC. Here all the supply has to be in the form of DC only. Here in the all the cases, the form of supply will be AC only. So thank you.